G'day Bifrosters, welcome back to the howling desolation that is my YouTube channel. I'm back. I've been very busy and hopefully we'll see the fruits of that labour shortly. I'm pretty excited about it, but I can't tell you anything about it, so you're just going to have to live with that. A good way to kick things back off would be to do one of the Frostini tutorials. So just take a Houdini node and make it but better. Houdini but better, if you're going to put it into the common parlance at the moment. So I did. Here we go. It's the line. That's what that looks like. That's what that looks like. It draws you a line. It allows you to set a point and a direction with a length and some points in it that you can change quite happily. You can lock the origin point. You can lock the end point. You can smooth out the line, which I will get to in a minute because there's nothing to smooth right now. And then we're off the rails. We're off the Houdini rails from there. The Houdini line node gives you origin, direction, length, number of points. It allows you to make a NURBS, a Bezier, a polygon, or something else. Oh, just points, sorry. Yeah. Sorry, my bad. Some of those are not relevant to us because if I was to say output that, that's now a curve as far as Maya is concerned, so it is a NURB. And I've got the points coming out, as you can see. Anyway, line. So yeah, that's everywhere down from here. It pretty much leaves Houdini behind. So you can change the direction that line is going in. You can make yourself a happy little displacement with it. I'll just pop that in there. There we go. It's displaced. And because that's kind of chunky, let's give it some more points. So it's not quite so chunky. It's still very sharp. If we want to say average those, we can smooth that out. We can change our smoothing iterations. It'll just get smoother and smoother and smoother. Of course, because it's a noise field, you can plug in frequency, change it a bit, come back, take the points down, take the points back up, unsmooth it, smooth it again. It's all nice. You can display the point sizes. You can turn off the display if you want. You can show the point ratio. You can show the length ratio, which is slightly different and also quite useful. Do that. You can enable arrows. So right now the arrows are pointing along the normal of the points based on the curve. What would probably be a bit more useful for us would be the tangent. You can change how long those arrows are. There we go. Smooth that a bit more just so you get the idea. And yeah. So this is what my brain decided was a good idea to do when I saw the Houdini node. And as I do, I will really quickly take you through it by really quickly rebuilding it. So I'll take off our displacement. Let's just get this a little bit reset. That's not fun. Oh yeah, turn off smooth. No smoothing it. Back to 1. Still showing our tangents. We're all good. Cool. So let's get this back to the vertical just for fun times, and we'll make another one. Going to need a compound. There we go. Inside that compound, I'm going to need a couple of value nodes, with one of them being a vector. Cool. So pop that in there, and then pop it in there again, and then pop that down there, and we're good for now. You guys can get out of my way. Lovely. This will be our origin. This is going to be our direction. And this is going to be our length. Lovely. Right. Let's get going. So we'll start off with an origin of 0, 0, 0. No, we'll start off with an origin of 1, 0, 0. So it'll turn up here somewhere. While we're building it, we can see what's going on. What I need to do first is normalize that direction. I should probably give it a direction, right? So just straight up's good. Normalize direction, and then probably give it some length too. Might be a good idea. Great, and we will multiply our direction and length, and then we'll take our origin points, add them to that. Like this, and let's just construct the string. Of course, that's not how you construct a strand. Strand wants an array, and because we're just doing a line from point A to point B, and everything else we do happens after this construct, we don't need to worry about strand offsets, we don't need to worry about substrands, we don't need to worry about all of that. We're really, before we do anything else in this compound, we're just creating a 2-point strand. So we'll start from the origin, it's a good place to start, and we'll finish on the normalized, multiplied, and added origin point. So this is the guts of it. Let's put down a terminal. Drop down a terminal here. There's our line. Lovely. Let's get it looking somewhat like this straight away by throwing in a point scope. This is all pretty easy stuff right now, hey? It's all pretty simple. Make sure we've got a line in here as well. So I want that to be color, I want that to be 0, 0.4, so we're not nice blue ones, and let's just get that roughly the same size, something like that. 135 looks nice. No arrows yet, but we can have them. We've just got no property to put them in. So I would think that at this point you're starting to see how this node is constructed. There's a few gotchas which I wanted to run through, but with the addition of one thing, which will be a resample strands. The addition of this, we turn off spatial because we don't want spatial. We'll set this to 10 just for light, just for fun. Plug it into the point scope, and we'll plug it into our output diagnostic so we can see what's going on here. If I just take our constant count, which we've set up for 10 points, drop this out. At this point in time, you've made the Houdini node. That's it. It does everything the Houdini node does. You've got origin, direction, length, and constant count. Constant count being number of points. Points. Oh, I'm sorry, I appear to have rented second-hand fingers today. Number of points. So at this point in the game, you have everything the Houdini node does. Here is a couple of the gotchas. Here's the first one. If this number of points drops below 0, my machine crashes. So the very first thing I need to do is set up a bit of logic to stop that happening. And that's real easy. If I go less, not even less, let's be a little more professional here, Val. If I go less or equal, so if I say, if the number of points is less or equal than 2, that statement in there quick, then if that's false, if it's greater than 2, then I just want whatever number I've put in. But if it is less than or equal to 2, I'm just going to set that to 2. So that it'll never drop below 2 and hopefully never crash my machine. We'll pop that out. That's all fine. Let's just set this to 1 and we've still got 2 points. There you go. So that's working. I'm a bit scared to go -5 and see what happens, but you'll just have to trust me on that. You know what? Why don't I save that? Put my faith in my own thing. Yeah, it hasn't broken. That's great. Okay, we'll go back to 10. There we go. So that's our first bit of gotcha logic. Just making sure that the number of points we're resampling our strand to does not ever fall below 2. Right. We're safe and set up now. Like I said, this is now doing everything the Houdini node does. So video over, right? Tutorial done. Val shows you the simplest thing in the world and everybody's happy, but everybody's not happy. I'm not happy. I hope you're not happy either. Because I want to get some of this functionality into it because, let's face it, we're not using Houdini, we're using Bifrost. And this is much, much better if I can do cool things to it, like displacement, whatever it is I want to do. We've got it here, we're building a tool, let's put in all the functionality we can think of. So the way this is working, and this is, you know, you can do all this in Houdini too. Don't get me wrong, this isn't a rant on Houdini. That was version 2 of this video, which I decided was a load of rubbish and threw away. This is about, it's about what the power of Bifrost is, and the power of Bifrost is that you can just keep adding stuff. You know, you can do a really simple thing, you can throw it into a loop or an iterate, and you can suddenly do really complex stuff with it. This is not going to be really complex stuff, but it should illustrate that. And how it illustrates it here is this setup. No matter what we do past this point here, past our construct strands. It's resample, doesn't matter. Whatever we do, we're just adding to, we're doing that Bifrost adding to thing, added value thing. We're adding to this, which is just really, really simple. I'm going to make 2 points. No matter what you've got plugged into here, this produces 2 points. The origin and end. And that's it. That's all. So, moving right along. Let's add the displacement now. So what I'm going to do to just facilitate all this, I'm just going to put in a pass node so that I've got some room to work. We'll put those out here. I'm going to take this guy and I'm going to plug him in there and I'm going to plug him in there. So now whatever we can do in here, and I don't have to keep rearranging my graph all the time. Let's displace these points. Displace points. Put that in there. Now, nothing happens. And nothing happens. You would expect something to happen because the way displace points works is if nothing is plugged into the displacement vector, it'll displace by the normals of the points that you're displacing, right? That didn't move. Nothing happened, which means this doesn't have any normals. Just to get displace points to work, we need to give this strand some normals. So if we take a look at this, we got nothing. We got the position of the points and we've got the strand offset, which is generated automatically. We got nothing. We need normals in there if we want this to displace at all. So the way we can do that is we can just go update strands basis right there. Update strands basis. It's another Rebel Pack node, and don't fret. I'm going to localize this before I output. But what this is going to do for us, and we can jump in here and see how it works. Recompute tangents, update by walking, update by from single normal vector, all of that kind of thing. This is going to generate our tangent normal and binormal for us. Now I'm going to tell it to force update tangents because I want it to, and I'm going to leave the up vector as it is right now. And now once I plug this in, still got nothing. Let's check that we've got something going on here. Now we do. We have a point normal, we have a point binormal, and a point tangent. Great. Watch what happens when I change the direction. But as soon as I lie this down, and point it in a different direction, there will be a gap of 1. So yeah, that's from 0 to 1. That's all at 1 because it is displacing by the normal because I've got nothing plugged in, the displacement vector. So we don't really want to do that because if you've got nothing plugged into the displacement weights, you don't want this thing to jump around. You just want it to do what it's told. Basically, you want to say, hey, I'm making a line that goes from here to here. I didn't want to make a line that went from here to here along all the normals. So let's fix that. And this is going to be our second bit of dodgy logic. Not even dodgy, just logic. So what we've got here in the displace points is an interpret autoport as scalar. And this is a great node. Converts various inputs into type array float, right? So no matter what you plug into there, it's going to spit out an array float. The catch is you have to plug things in there that are kind of floaty, that are kind of remotely related to floats. So a single float will work, a scalar field will work, a float array will work. All of those things work. A vector array won't. Neither will a vector field. Okay? So the nice thing about this, and given to us by the gods of Autodesk, is this has data. If you check this has data, indicates whether a valid input is connected to interpreted scalar port. Basically, it only returns true when it's a float value, a non-empty array of float values, an array of long values, a non-empty scalar field, or a string. That is the name of the valid property on the geometry. So we can use this. And here's how we will. Remember how I said that if you've got nothing plugged into your displacement weights, actually, I'm not. So let's put down an input. And we'll use this auto port here. Well, I mean, we need to output our displacement inputs anyway, so let's just hook all that up to start with. And you remember when I said that we don't want this to displace anything if there's nothing plugged into it, right? At the moment, there's nothing plugged in there. There's no displacement on that at all, yet it is still displacing. We don't want that to happen. So this is where we'd use, as I said before, we interpret autoport as scalar and we just drop in the weights here. And now, if there is nothing plugged into that, or if the wrong thing is plugged into that, or if whatever is plugged into that has no data, this guy is going to come through as false, which simply means we can go if put it into the condition, not the true case to start with. Get rid of that. If this has data, cool. We're going to take our displacement scale, pop it into the true case, and then hook this up to scale. But if it doesn't have data, if it's false, then we're going to leave that at 0. And what this is going to do, and you can see it's done it, is it's going to scale our displacement to 0, which is effectively means no displacement, but it's only going to do it if there's no data coming through that port. And I'm just going to make sure everybody's happy and plug in this to our geometry just to get the node to work. This needs the same number of points in the array as it has in the geometry. So if you wanted to displace this and you put in an array of 20, and you wouldn't, actually I don't know what would happen because of field works. Let's try it. So just for smarts, we'll grab this guy and we will create a value node out of him. So there's 10 points. And I'm just going to get twice those number of points just to see what happens. Yes, this is one of those videos where I go ahead and make some really simple node in the most complex way possible. Random value array is what I wanted because I want random values. Throw that into the size. Seed is fine, and from 0 to 1 is also fine. Let's just plug this into the weights and see what happens. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It seems to work. Awesome. And it's displacing, and we're all good. Displacement scale is working nicely. So, yeah, there we go. I have answered my own question. That seems to work fine. Please ignore everything I said about it. Back to what we were doing. So we now have displacement. We now have displacement working. Now we've got origin, direction, length, number of points, and scale. We don't want scale. We want displacement weights, displacement scale, and displacement vector. Cool. We're all good. We're here. We're running. We're up and going. What do we do now? I'm going to rename this for a start. 1, 2. Will do. We'll try and make it pretty as this later. So what else did we have up here? Well, we had lock origin, lock endpoint, and smooth. So this is where we can start thinking about implementing the smooth. And I'm not going to show you how to do that, but what I'm going to do, I'm going to give and show you the compound I made to do it. I'm going to show you how that works instead. So what we've got here is a little compound called quick average. So now, let me show you how this works. First thing I need to do, of course, is to reset everything. So we'll reset that. Oops, wrong way. Yes, I've been away for 2 hours fixing quick average. And it's still not perfect, but it's close. So what quick average does is it lets you smooth out the points. So let's just plug that in and see what we've got going on. Let's just change this to 1 right now. So we'll plug that in. And you can see that it's starting to smooth the points. Make this higher, and the smoother they get. Now the issue before was that the endpoint wasn't staying anywhere near where it should be. And it's still moving around a little bit, but it's the best I can do with 2 hours work later. So anyway, this is still working as a smooth. We've got a couple of issues here. We've got, like, if the smoothing drops below 1, or the iterations drop below 1, everything just disappears. And that's about it, really, the way that this works. And I'll take you through it really, really quickly. So it gets the point positions, first in array, last in array. Last in array gets fed into the iterate. Now the iterate is what does the averaging. Inside of here, there's a for each loop. And that's where that last of the array is going in. And what this is basically doing is it's averaging the current iteration, the previous, and the next to smooth it all out. So averaging by adding them up and dividing by 3 because there's 3 of them, which is cool. That can come out. What the rest of it's doing is it's setting conditions on the next and previous iterations. So it's not trying to grab a point position in the case of the previous. It's not trying to grab the point position at -1. It just grabs 0. And the same with at the other end, at the next one. But what this is also doing here is it's looking for the last, basically the last index. And if it finds it, and finds it twice, which means that the current and the next one have come through as that index, then what it does is it sets that point, which will be the last point in the loop, it sets it to the end point, which we've brought in from before. So that's how we're getting around that. But anyway, so back to work, back to building our line. First thing I want to do is I don't want it to smooth all the time. So let's throw down, before we do an if, let's throw down another input node. There we go. And we might as well stick the max iterations out here. We'll come back to that in a minute. And I'll just quickly throw down an if that says, hey, do I want to do smoothing? So if I don't, false case, I'll just put out the displaced points. If I do, let's put out these average points. And then we'll hook that up to the pass. And there we go. So right now, as you can see, the smoothing is off because this condition is off. On, off, on. You get the idea. So we'll plug that into our input and we'll call that smooth. And we will call this smooth iterations. So the only other thing we have to fix now is if our smooth iterations, I've got smoothing on of course, our smooth iterations drop below 1, everything disappears. And we know how to fix that. We just do less or equal to 1, then an if statement. So if it is less or equal to 1, well, if it's not less or equal to 1, we just want whatever comes in. If it is, we want to set that to 1. Then we can pop that out to the max iteration, and we'll just move all this back to keep things a bit tidier. We need that output later, so we'll move that over there. Great, so now we've implemented smooth, which is cool. You know, we're building this thing one thing at a time. It gets smoother. You see I can go as far down as I want. It just doesn't matter. Turn that off for now. So what now? Let's get rid of this working stuff I was doing. Well, we don't have to lock the endpoint anymore, or the origin, because they're both locked anyway. So those two are going to come out. Here's our smooth, here's our displacement, and now it's all about display, and then we're done, pretty much, with a little bit of organizing. So let's go work on our display, and we already have a display here. What our display is this point scope. So I can do all the things I want in here. I can change the size of my points, which is great. They're set as a disk. I can change their color, which is cool. And at this point, I can now enable some arrows. And if I say, look, what I want on my arrows is my point tangents. So that means I just need to check and see, I have tangents coming through. There they are. But they're not showing me my arrows. So let's see what the normal does. Let's see what point normal does. It's point tangent. That's why. Now, this isn't quite working right, is it? What this is doing is it's giving me the tangents from, whoops, I went one bit away. What this is doing is it's giving me the tangents from where we set the tangents. And if we look at where we set the tangents, it's here, before we do our displace points and our averaging and everything. So we need that in there to get the normals for the displacement. What I need to do is do that again. And I need to do that again right here before the point scope. So let's just do this, update, strands basis. We need to turn on force update tangents, I think. Go back to our point scope. Yes, there we go. So now you can see these tangents are all over the show, but they're pointing along where we want them to be. So let's go back out one, smooth that. You see the tangents change. And our point scope is like maybe scale the arrow length down a bit. And then we can come back to here, and if we want to, we can, let's just smooth that. And you can see there's our tangent arrows working. So we have a display already. It's in the point scope. What we need to do is get those displays out. They can go away now. get those displays out as inputs, or those things we want to display. So let's do that. Put that in input node. So now we just need to decide what we want to be able to input. So I want to input the point size, which is great. I want to input the color, also good. And we'll leave everything else as it is. We don't need to actually bring this one out. Then we'll need to, do we want arrows? What property are we going to display arrows for? And how long do we want the arrows to be? So now, if we come back out, we have all of these settings. We can address them from here. So maybe I don't want to look at the tangents. Maybe I'd like to have a look at the point normals, please. There we go. So there's the point normal of that smooth curve. Now you'll notice that we've lost our strand, which is fine. That just means I need to output this guy back into diagnostic for now. And there he is. So I'll update this. And just for now, we'll change the points here. We'll give it some more points. You can see it building them along with the normals. It's all very quick. It's all very good. And grab this one. Let's just make this a length of 5. There you go. So we've got this great big long line filled with random values, which let's get rid of that now. Just fine. It's going to go back to just a straight line. Get rid of that. And we'll drop in a noise field instead. So that just goes into weights for now, and there we go. There's our smooth line, and we need to change our number of points back up. There we are. So functionally, this is working. This is all doing as it should be. You can still, of course, because it's procedural, you can change its direction. Now it's going to change its shape because it's moving through a field. You can change the length and the number of points. You can scale the displacement. Change how smooth it is, or not smooth, as the case may be. Change the default size of the points. The arrows change with that as well, but you can also change the length of the arrows. So, and then change our property to whatever you want. So we've done it. We've built this line. Why does this line not look like this line? Well, it just means we need to add a little bit of an interface. So we'll add this to a group. Construction. Just make sure we've got all of this, and that goes into the construction group. And that goes into the construction group, and so does this. Now, we don't need lock origin, lock endpoint anymore because I went away and worked that out. It took me a couple of hours. So essentially, all we need to do is add smooth and smooth iterations. And there's our first group made. You can see it's turned up here as well. And then here, we need to add it to a new group. Displacement. And that's that done. And then this guy, we just add to a new group again called display. And with that, we have rebuilt the line node. A couple of things that are different. So you've got all of your terminals showing up in here. That's just because we need to turn off those two. And the other thing that's different is that line 2 has no output, has no strand, no point output. So let's output those two. Get that down to the end there. So the strand is easy. So yeah, the terminal is what's going to show us the points, but what we want to output is the strand, like so. Nothing much changes here. You can probably still see the strand. Let me just turn off the arrows for a sec. And you can't because we don't actually have this hooked into anything. So let's have a look at the terminal, and we'll just plug the strand in. We'll get our line back. That's great. That's awesome. Last thing, we want to actually output the points that make up the strand as well. Easiest way to do that is just to grab this, get point position, like this, and we'll just re-output the strand. call those. And then we'll go back and fix our spelling mistakes. Strand of points. Strand of points. Oops. And we're done. Apart from the funky logo, which is a different thing, and you don't really need to work that one out just now. But we're done. All right. So yeah, that's basically just really quickly going through how you take a simple concept and improve on it and improve on it and improve on it. I can still turn off my smooth here, and I've got my line just as it were. And I can still do all of the stuff like controlling the length, controlling the displacement scale. You know, it's a bit hard to see now, so we maybe like shrink those points down a bit. All of that kind of thing. Yeah. So, happy building. Yeah, go off and make some good notes with it. I've already used this a couple of times in my day-to-day life. And hopefully it'll be useful to you as well. All right. Thank you very much. Have a good night.